Hello everybody, and welcome to Escuela Unisabana Tips. Have you ever asked what would happen if a store that is very efficient removed a worker to minimize its costs? Well, this is more common than usual. That's why we decided to investigate in our university, to show you, in a better way, this type of cases. This place is the coffee shop located in the library at the University of La Sabana. At first, we identified this as a one-channel, one-phase service line. This is because you get there, do the line, pay in one cash register, and then wait till your order is ready. In addition, as it is a Moniz and a PAT student who are offering the service, we can affirm this is an exponential distribution. We decided to propose the next question. What would happen if a store that is very efficient removed a worker to minimize its costs?
As we wanted to know what will happen in the system if one worker was removed, we needed to recollect some data that help us identify how the usual service and arrival rate was at the coffee shop. We went there on 3 different days from 10 a.m. to 11 a.m. After we recollected the number of clients and the time passed from when they paid till they received the order, we did a calculation of 7 variables. At first, we identified that the arrival rate is 13.667 people per hour and the service rate is 58.064 people per hour. With this information, we could calculate the use of the system, which is the arrival rate over service rate, and it is 23.54%. With this, we can identify why the service rate is so fast in this shop, and that this place could receive more clients. Additionally, we could estimate that the average number of people waiting in the line is 0.0724, and that the average number of people in the system is 0.3078. With this information, we could calculate the average time waiting in the line is 0.0053 hours, which is 0.31808 minutes, and the average total time in the system is 0.0225 hours, which is the same as 1.3514 minutes. After we got this data and we observed the behavior of the system, we could recognize that it was very efficient. That's why we identified it has a bottleneck in efficiency, because the service will remain mostly the same without the PAT student.
Added to this, we assume that the work that the PAT student contributed was at 30% in total, which allow us to calculate what the service rate would be if only the Moniz was working. The service rate would change to 40.645 people per hour.
In this case, the use of the service would increase to 33.62%. Added to this, the average number of people waiting in the queue increases to 0.1703 people, and the average number of people waiting in the system is 0.50675 people. Having this information allowed us to calculate the average waiting time in the line, which is 0.7478 minutes, and the average total time in the system is 2.2239 minutes.
In this case, we can affirm it because the store is not really known at the university, and this allows the service to be efficient with only one worker. Additionally, the percentage of the jobs done by the two workers are not equitable, which means that one does the 70% of the work, meanwhile the other one just the 30%. This allows us to conclude that the 7 variables are not going to change in a remarkable way. Consequently, to improve the system, we recommended removing the worker that contributes less to minimize costs in the store.